an automated bending unit for shell bodies with a capacity of 100 tons. In this article, we would like to introduce a 225-ton automated bending unit and discuss its differences. We will also demonstrate the bending action performed by the 225-ton bending robot -G. Compared to the 100-ton unit, the 225-ton bending unit is commonly used for bending construction, such as the side panels of high-voltage cabinets that we are currently bending. On the other hand, the 100-ton unit is often utilized for bending smaller components like instrument doors. Let's take a closer look at how the bending robot operates. First, it lifts its right arm and carefully positions the iron plate in the designated spot. The bending robot then proceeds to grab the plate and perform the bending process. Throughout this operation, the robot movements need to be precise, ensuring accurate placement of each object. This level of precision and coordination demands exceptional performance from the robot. To achieve this, the robot is equipped with an advanced control system that can precisely control each joint's movement. It is also equipped with high-precision sensors that continuously monitor the position and orientation of the objects being manipulated. These sensors provide accurate data that helps the robot perform its tasks flawlessly. In summary, this bending robot demonstrates the extensive use of robotics technology in the industrial sector. Its presence not only improves production efficiency and reduces costs, but also presents new opportunities for the development of our sheet metal manufacturing industry. As robotic technology continues to advance, the future holds promising prospects for even smarter and more efficient robots. With this automated production line, we can process cabinet components continuously, enabling us to provide our customers with high-quality, standardized, and on-time delivery for both high and low-pressure shell bodies. This not only benefits our customers, but also enhances our own operation.